Alright, so today you're going to know, Jaden, I need you guys to leave the chairs down because there's enough that are broken, okay? Please don't lean on them. You're going to know the difference between an example and a conductor. You'll know some examples and you'll be able to determine Adam's charge. Hopefully Mr. Love taught you that. And you'll be able to decide which object has a greater electron affinity, which is what we were talking about just there when I was doing that little demonstration. So let's begin. Most of these next two slides are going to be review. Okay, from Mr. Love. Right? So the modern atomic theory states atoms are made up of positive particles called protons. You learned that from Mr. Love. Negative particles called electrons, and neutral particles called neutrons. You should know that already. Jared, do you know that already? Yeah, you should, right? And that's kind of what they look like, right? The nucleus has the protons and the neutrons, and the electrons are whizzing around the outside. Right? Protons and neutrons are found in the nucleus of the atom, while the smaller electrons orbit around the nucleus. So this sort of started to come around about the late 1800s, about when I was born. No. What year was I born? Remember the least one that cup the year before? 1968. Yeah, it was the least one in 67. They won a game last week, eh?
Yeah, it's first.
Of course, they did play a minor league team. Any other fans? No? Okay. There are Oilers fans. The last time I asked them, there was 2 or 3 of them in the room. Okay. Everybody good? What was going on, Charlie? Charlie. Mr. Casanova. Mr. Casanova, thank you. Okay. Reed, I'd like to continue, please. You can discuss it with Charlie later. Atoms are electrically neutral. Okay? Atoms are electrically neutral. Everything up there on the periodic table is neutral. Grady, what does neutral mean? Not a clue? Didn't you just come from chemistry?
Yeah.
Well, it's not going to work, man, because grade 10 you got to know that all that stuff.
Neutral.
Neutral, what does that mean? No charge, right? It's like free lunch, no charge. It means that the number of protons is equal to the number of electrons. You probably learned that in chemistry.
Yeah.
You should have, right?
That's how you figure out how many atomic number.
Exactly. Okay, so for example, oxygen up here. Read what number is oxygen on my PR table. Number 8, right? Oxygen has, Chris, because it's number 8, has 8 protons. Jonathan, 8 protons, 8 neutrons, 8 electrons. It's neutral. Mason. You could, yes. You guys probably have seen Bohr models, right? 8 protons, yeah, I know you did. And you'll have to draw them again in grade 10. Right? It's neutral. Great. I need to listen. I know. It's no review. I get that. I'm just going to continue on, okay? Because you're distracted by it. I can see.
What?
Well, you did that wrong. There should be 2 in the first one.
There is. There's the red ones right here.
Well, there should be 1 on top.
Oh,
No, down. Wait, down 1.
it should be.
Down one? Oh, yeah, one there and one there?
No. Where 8p is, there should be. Just go up and draw.
Okay, so this is, okay, I got you. You want me to draw it like this instead?
We were.
Okay. Reed wants me to draw it like this. He wants me to write 8p and then like that? Okay. You're one of those guys.
That's wrong. That's not how it was.
Thoughts? It really doesn't matter. Doesn't matter. Grady, I need that chair down, man. Please. You can't lean on them. They bust.
We just need one.
They bust.
That's what my parents always
I know.
say, bust.
Well, they do. I've taken 2 down and they bust.
Well, every time I do it, none of them bust. Shut up, your parents.
You're making them loose. Okay, so anyways. Grady.
I guess we got solid wood chairs for it.
Want to play basketball as we try?
That's a real
Well then.
We're going to bush.
So, the particle model of electric charge. Read.
$10,000.
Here we go. Developed from 20th century experimentation. Charge is a result of the presence of a positive proton, a negative particles, protons, and neutrons. So this one here, which atom is this? Which element?
No.
Number 11?
I can't even see.
Yeah, it's kind of, yeah.
It's NA. What's that?
Na is? Sodium, right. Na is sodium.
You guys are playing over an empty snap.
I think you got it there, right? On the next page, right? Are you guys flipped to the next page? Reed, have you flipped to the next page?
No.
Yep. Excellent. Excellent. Okay. So, oh, you didn't have that? You guys done with this?
No, I want to take a sip.
Okay, Reed, let go.
I want to take a sip.
Finish it up, and then I'll get rid of it for you. That's for him? Are you all done with it? Okay, so where are we at?
What's the next snap when you still on the
Chris? Okay, well, let's go through here. Okay, well, let's talk a little bit about that. Okay, so case number 1 is... What? You're not making steel drums out of snapple cans. Come on.
There's still snap on here.
Okay, drink it.
There's still something there for you. I heard it.
Down it, let's go.
Chuck it.
Come on, get her done, let's go.
Okay, I can't say. Yeah, because that works.
All done?
There's only 25 cents now.
Okay. So, they can be neutral when they have the same amount of positive and negatives. The overall charge is a big fat 0. Right?
I was just looking right in the back.
When you were running the auto or shop?
Chris, got this one?
Oh, which one? Where did you even say that?
Sure it does.
Oh.
Yeah. 3 states, right?
Oh shoot. I'm not stuck.
What?
Why are you talking about Chris while he's not?
Well, that's what it was actually talking. Great.
What kind of hamburger? All those street ones? Yeah. Oh.
You're what? You're behind. That's very top there. Like 3 states, see?
No. No, he made big A-pains.
Did you?
Yeah, you did. You're really big. Kelsey, you need the throttle extension. You're stupid.
No, it actually fits. With the slit.
Keep going, Charlie. You're behind. I'm waiting on you.
Brandon.
No, I'm not waiting on Brad. He's done.
Brandon is going.
No, this. No, no.
What do you mean no? I'm reading it.
Pay attention to what you're writing. No, not talking to Brandon. No, Charlie.
Hey, I started trying to doing like 160 or
Read. He's trying to learn something, man.
And you almost gave full
Yeah, this is one ski just got a big riff.
Are you done?
Did you tell Tyler that?
Okay, we're going on, so pay attention.
I told him, but Charlie.
Great. Next one. What's the second one?
What were you telling me?
The second case, Charlie, is that they can be positive. In this case, there's more positive particles than negative particles, so the overall charge is positive. In other words, there's more protons than electrons.
Hey, go put your fingerprints on there and then I'll go rob the bank. That's good.
Brandon. Okay, Chris, no, we're trying to get through this. You guys got to stop having these side conversations. I don't care if he's trying to learn something. You're distracting him. Stop having side conversations.
No,
Now.
you could multitask.
No, you can't.
Yeah, multitasking.
No. You may be able to write, but you're not learning anything. And it's going to show up on the test, and then you're going to be back doing grade 9 all over again.
No.
Or doing it all in study. I know you've done this, so this should take like 30 seconds to go through.
No, we want to multitask.
No, you do not multitask.
Look at, see, an object can be negative.
The third case is negative, right? Object can be negative when there's more what? No, what kind?
Negative.
More negatives, more electrons.
See, we're
Excellent.
learning and we're talking at the same time, see?
Collaborative learning.
That's, if you're talking about this, I got no problem with that.
Hey man,
How
did you
about-
hear that,
how about that
an object can be negative if it has more negative particles?
How about that positive charge in that city that you take with?
Yeah, see, there's so much positive charge that you couldn't handle the throttle with it.
Okay. Hold on. You need the clickers. Are the clickers there? Get the clickers out. Here we go.
I don't want to talk now.
Well, that's a janky.
An unknown atom has 8 protons, 10 electrons. What is its overall charge? Charlie, I've been teaching it for the last 10 minutes.
Anyone?
Same one.
8 protons, which are positive, and 10 electrons, which are negative. There's a picture of it right there. What is its overall charge?
I don't get that.
I don't get it either. I'm confused.
What was I just talking about here, you guys, when you were multitasking?
The only question.
It's the only question.
What? Got it right. I think.
Remember I was talking about this here, and you guys were like, oh, remember that?
In this case, object has more...
8 protons, 10 electrons.
You have advantage.
Yes.
Did you answer one?
No,
Okay.
Come to Jaden.
I'm waiting on Jonathan and Brandon, Alicia and Chris. Okay, great, stop. I just taught it here, you guys. Remember when you were writing this down? I just went through it.
Oh my God, couch, dude. One answer.
Got an answer, Jonathan?
One question.
Yeah, it's a letter over here. A, B, C, D, or E.
Oh.
A, B, C, D, or E.
Is it true, couch?
B.
No, it isn't.
Yeah, it is.
Hurry up. Hurry up, Ben. Enter an answer.
Because if there's more, if there's less protons than electrons, it'll be negative. Right?
It said right there, couch.
Answer is B. Circle the correct answer on your sheet. Circle the correct answer on your sheet.
I put 10.
Question number 2.
Divide?
Question number 2. See if you get it. Unknown atom has 6 protons, 6 electrons. Its overall charge is A, B, C, D, or E.
7.
Yeah.
I like seeing.
Moving on, you guys. Moving on. Which subatomic particles, and I know you know this answer.
This is a piece of junk.
Brandon. Settle. Which subatomic particles are actually doing the moving? Valence what? Electrons. Right you are, Reed. The protons are fixed in the nucleus. They're stuck there. They're not free to move. The electrons are free to move. So it's the electrons that are transferring from one to the other, the rabbit fur to the glass.
Do we just shut the off?
There might be some more coming up. I think you just hang on. Okay? You need to know that it's electrons that are moving. You need to know that it's electrons that are moving.
Hey Chris, are you finished?
No.
So you can have babies?
Our topic
You tell
was
me.
Answer. Next time,
Yeah, we're
I will bring your slide.
I didn't make
Good, it doesn't have any strings on it.
until now. Until
You can
now.
just walk.
Okay. Mom,
When it's on fire, then I'll just...
Okay, we're getting real close here.
Hey, can I do something real quick?
Huh?
Can I do something?
What? No.
You just
No.
number.
No.
Your number's gone.
This guy hit a church shot. He's like, "Oh, Mom."
Brendan, which particles are moving? Protons or electrons? You don't know? You're just writing it down, man.
Electrons.
Electrons are the ones that are moving.
How do you get that from again?
Oh.
Dude never rose rather than him.
That's Dr. Alexander's fossil. Where's Charlie?
He's not allowed to.
Oh.
No, that's not right.
Look at Charlie. There's so much frostbite. You're just proper.
Yes, frostbite enough is frostbite.
Yeah, he's stupid. If it wasn't for Dick, then that's the stuff. I'm warm with Bella Slava.
Oh, I got really bad frostbite when I was right behind you on the RXL, like when I was riding double.
Oh, yeah.
There'll be a
I've
chance.
never done frostbite before.
It's important to
If you
know
get
that.
it, you're gonna get it twice.
Okay.
And that's true.
When I say conductor, am I talking about that guy?
No, you're talking
No, I'm not talking about that guy.
Okay. Talk tomorrow.
Conductors allow what to happen? There.
Conductors allow electricity.
Yeah. Conductors are substances that allow electric charge to pass them easily,
That are not.
right?
I
don't have it.
Allow
Electric
have
charge.
conductors have.
Very close to my back.
You need to.
Oh, I need to fix it?
You need to swirl.
Substances that allow electric charge.
Three conductors have electrons that are not. That's what I know. That are
Now,
not.
a conductor has electrons that are not strongly held by the nuclei, and as Reeves pointed out, they're always called the valence electrons. Some atoms are stronger than
Strongly
others.
held by their what?
Nuclei. Nuclei. Some atoms, some elements have very strong hold over electrons, other ones do not. What is an example of something that conducts electricity? What do they make wires out of?
A conductor.
Copper. Copper. They make wires out of copper.
You know what else they make with copper?
Grady, here's copper right here. Cu. If you know something about the PR table, you'll know
Yeah, where's one of those?
about those.
Mr. Lumsey.
That would have helped us so much.
Yeah, I know.
So, Chris,
Oh,
conductors do not hang on to their electrons.
we get this thing.
They're sort of weak. They allow the electrons to move easily along the conductor. So that's why we make wires out of copper. Grady, why do we make wires out of copper?
Because it's so conductive. It
How come?
flows so
How
easily.
come?
The electricity just flows through the
How come?
So how can they put a rubber coating over the wires? That rubber coating
That rubber coating is not
prevents
conductive, it does
Yeah,
not.
so you don't get the shock on the outside.
it takes away the electrons and it doesn't pass through enough.
It's an insulator, right?
No, it isn't. It takes away the conductor. It's just
Well, it allows
because
it
if
not
you
to
take
conduct
off that
the
rubber, then it just be good and flow. It flows right.
It would still flow through the wires when they're rubber coats. Still flows through them.
So if I took the rubber coating off.
So how come I wear rubber boots and touch electric fence like a sophomore?
They still are.
It's not about that. It's because the electric fence doesn't have, if the electric fence had the rubber coating on it, you wouldn't get shocked.
Well, how come when I have?
I don't know why you would work more with rubber boots on. It doesn't make sense.
Yeah, because when I'm say if I held this and I touch Brandon, it's soft.
Yeah, I know that, yeah. But I don't know why it would be with rubber boots on it.
Yeah, I don't know, but if I just had little shoes on,
No. Read, no.
That's so cute.
Here are some examples of conductors.
I like how he commented on there.
First of all, what are some examples of conductors? Yeah.
Oh, I did a rope, like a driveway gas this thing. I did mine
Human
at zero
conductors.
bars.
Exactly. You're all done. Good.
There's a better one. The second one is better, but we can go.
When I say insulator, read, am I talking about that?
Yeah, it's along the line.
I'm talking about the thing on the outside, Mason. Right. When I'm talking about insulators, I'm talking about... Chris, my turn. Chris, you guys gotta learn like the give and take. When I'm talking, you be quiet. And when you're done, I'll let you talk a little bit. But you gotta know when to stop.
No, but it's not just us.
I know it's not just you. But I'm saying all of you guys gotta learn that. Derek, it's gotta learn when I start using that big teacher voice, time to shut the conversation down and listen. It'll go a lot smoother for us all. Examples of insulators. There are substances that do not allow electric charge to pass through easily, like the rubber around the wires. Insulators have electrons that are more strongly attracted to the nuclei. They're strong. Rubber hangs on to its electrons. Electrons are unable to flow. And here's some examples. Read, if you know what electric fence is, you know what this thing is right here.
Oh, I shoot those things on top
Oh, that's electric fence.
It's electric fence insulator, right? So that the electricity doesn't jump to the post. You probably have seen these things out in the country. Insulators as well, right? Glass.
I shoot those with the hydrogen line.
Yeah.
Yeah, no.
Oh,
Yeah,
yeah,
you
it's a
guys
line.
smart. And then what happens if the line hits the ground?
Yeah,
Then I'm in my truck.
Yeah.
Yeah, you're shooting under your truck. That's one illegal thing. Shooting the hydro line is another illegal thing.
I don't care. What happens if there's a bird on it?
that's still illegal. It's maybe on an endangered animal. If you're shooting an eagle.
I shoot eagles.
Oh my god.
Owls.
I have no.
Whoa!
I shoot vultures.
Right here, man. Right here.
I shoot my neighbor.
I club baby seals.
My neighbor was shooting at me, so I just gave
Okay, I want to point out that very soon I'm going to ask you guys to do this, and some of you are going to be saying, I don't know, because you're not listening.
If you ever come to my house and you start
There's more questions.
Yep.
Actually? Yeah.
Okay.
I'm playing cops and you start shooting at you. Duct tape gun.
Duct tape gun.
Like, he doesn't have a barrel stock or anything, or he just has a barrel on the trigger. You tape across the
What kind of gun does he have?
MLG.
Does it, like, is
Okay.
it powerful gun will actually slide?
When I took the plastic rod and the rabbit fur, I don't know where I put that plastic rod. Oh, is it?
I sat on it.
Yeah. No joke. Being a fucker.
I'm not going to hear about my slide.
Ah, yeah, excellent.
If he shoots
Thank you
you,
for hanging on to that. When I rubbed it, I used friction here. Chris, here's the teaching part.
Until you die.
Watch. When I do this, one of these things holds on to its electrons more strongly than the other. So the electrons from the weak one go to the strong one. So an insulator can be charged. You can charge an insulator by rubbing it by friction, because this action could cause electrons to be pulled off of or deposited on the insulator. Because electrons are unable to flow, the transfer electrons will stay where they are placed. And there's a picture right there. This time I'm using glass and a silk cloth. What charge is on the silk? Can you see?
Negative charge is on
Negative down here,
Hey.
positive up here. Anyone want to guess what question I'm going to ask?
Is it a positive or negative charge?
I've already told you that.
Oh.
Charlie, we can move you over here so we can reach you.
Is this your last basketball game? When's basketball over?
For some, it might be sooner than others. I'm going to ask you which one of these is stronger, Reed.
Oh, the positive.
I'm going to ask you which one is stronger, based on what I've already taught you.
Right one.
Can I go to the next slide? The transfer of electrons is determined by what's called the electron affinity, or the strength. Another word for it is the strength. Electron affinity, or the strength. The one that has the higher strength, when two insulators are rubbed together, The insulator with the highest electron affinity, or electron pulling power, will take electrons from the other insulator, becoming negative. This paragraph right there is super important. Okay, that paragraph right there is super important. Put a star beside it. I will expect you to answer this question on the test. Okay?
I'm gonna study there.
Oh, I still gotta study, that's all.
It's going to be right here.
I don't know.
His neighbor.
The insulator that Chris. The insulator that loses electrons becomes positive. Brandon, I'm going to ask this question right away. You need to know it. Here we go.
Oh. I don't even know.
You're going to have to think. Why is the glass rod positively charged when rubbed with silk? Jaden, think, man. Why is the glass rod positively charged when rubbed with silk? Is it A, the glass is weaker, it lets electrons go to the silk? Is it B, the glass is stronger, it lets its electrons go to the silk? Is it because the glass is weaker, it lets its protons go to the silk? Or is it because the glass is stronger and lets its protons go to the silk? Which one of those four? You're going to have to think.
I'm scared.
Did you choose?
Yeah.
Why did you choose B? Because why?
Hey, you chose B too, man?
Why did you choose B, Charlie?
Why is B and
Okay.
C and A and C?
You know what? There seems to be this misunderstanding, you guys, that you're just going to get this credit. And what happens if you fail grade 9 science? You got to take it again. And until, right from the start.
We're gonna take like a
Yep, right from the start.
Oh, but I'm doing good science.
So go ahead and do nothing if you want, but you'll take it again.
I don't feel this.
I'm just saying, that's how it works around here.
Just
Jared
got
City-
one answer wrong doesn't mean we're gonna
And,
fail.
well, I know. I'm just saying that some people are just randomly picking numbers. Jonathan, what are you doing, man? Why is there someone named Jake signed in?
Who? Oh, that's the reason.
It won't be hard to figure out because it'll be whoever's here that isn't signed in. So, correct answer is A. I'm going to tell you why. Charlie, listen for the why.
But everything.
Just listen. Why is the glass rod positively charged?
Oh, because the silk is
This one is positive. This one is negative. The one that's Jaden, the one that is stronger takes the what?
Electrons.
The electrons. The one that is stronger takes the electrons. Do you have this picture right there? I don't think you do, right? It's on the back? Okay. So the one that is stronger, Dan, takes the electrons. Now, first of all, can we get rid of C and D? How come?
Because it says protons.
Because protons don't move, right? Okay, so it's either A or B. Which one takes the electrons? The one that's negative. The silk is stronger, which means the glass is weaker. You're going to see that question on the test.
So remember.
Next one.
Yeah, we're gonna redo ourselves.
Stop and think.
I don't know why. I thought it was a glass.
This is a different one.
Oh.
You got to think. Plastic rod, wool. The plastic rod becomes negative. There's the wool. Think. I've taught you everything you need to know to answer the question correctly.
Eeny, meeny, miny, moe.
No, not any, meeny, miny, mo. Who am I waiting on? Grady, Jonathan, Jared, and Cole.
Well, Charlie, what
I've given you what you need to know.
Oh, well, then I was trying. I'm gonna put this one was weaker, so it must be stronger.
All Grady's down shifting the whole front court. Nathaniel.
You can't put both. Grady, which one is it?
No! Ray quit.
Correct answer is B.
Oh.
Okay. There we go. Thanks.
Oh.
Why is it B? Braden, tell us why it's B.
Oh, it's big trap.
Braden, tell us why it's B.
Oh, I got hit.
You don't know?
You're
You're gonna need to know. Which ones can we get rid of right away?
In the last question, the wool was stronger.
In the last question, it was glass and silk. You gotta think. It's not that hard. Listen. First of all, C and D are out. Protons don't move. Plastic rod is negative. Which one is stronger? Plastic is strong. Wool is weak. The wool is weaker. That's B. Okay.
Turn these off.
No, I'm not done. I'm not done. Sit. We're not done. If the bell goes, you guys are staying till I'm done. I got to finish this. Pay attention. This is super important. Sit down. Sit. You're not going. I dismiss the class, not the bell. Don't even try to leave if the bell goes. This is important. Don't pack up. Don't pack up. Do not do that.
Don't do what? Open my mind.
Yeah, listen. I need 30 more seconds, and then I'll dismiss you. Listen. This is called the electrostatic series. These ones up here are weak. These ones down here are strong. These ones become negative. These ones become positive. Write that on there. I'm going to ask you to use that chart on the test. Okay? We'll check that tomorrow or next time, Thursday. You can return the clickers now.
Oh,